Hello everyone, and welcome to the AI Research Roundup. I'm your host, Alex. Today, we're diving into a fascinating article by Google Research titled Mind the Gap, Geometry Aware Passthrough Mitigates Cybersickness, published February 28, 2025. This post explores the problem of cybersickness in video see-through VR headsets. The core idea is that using Geometry Aware Passthrough, or GAP, can significantly reduce cybersickness compared to standard direct pass-through systems by creating a more accurate depth perception. This, in turn, should lead to a more comfortable and immersive VR experience. So, this figure illustrates the key problem with direct pass-through. The first part shows how the camera's view and the user's view are different, leading to disocclusion. Basically, the user can see things the camera can't. The second part shows how this difference makes head movements seem exaggerated in direct pass-through, impacting depth perception and potentially contributing to cybersickness. Alright, so this figure directly compares direct pass-through and geometry-aware pass-through. It shows a hand reaching towards a puzzle box. In the direct pass-through image, the hand and the box appear larger and closer than they are, kind of distorted. The geometry-aware pass-through, however, renders them much more accurately, closer to how they would look naturally. This visual difference highlights the geometric distortions inherent in DP, which contribute to the sensory mismatch and discomfort the study is investigating. So this figure shows the setups for the 3 tasks used in the user study. We see the typing task with a laptop and Dvorak keyboard, the navigation task involving numbered cones and waypoints in a room, and lastly, the interaction task, which is a jigsaw puzzle. These real-world tasks, requiring different types of head movement and visual focus, helped researchers assess the impact of DP and GAP on user comfort and cybersickness. Okay, so these box plots show the distribution of Simulator Sickness Questionnaire, or SSQ, scores for nausea and oculomotor issues. We can see that both GAP and Natural Vision, or NV, have considerably lower median scores for nausea compared to direct pass-through. Interestingly, for oculomotor issues, while DP still shows higher scores, the difference between the 3 conditions appears less pronounced. This suggests that GAP primarily improves nausea, a key component of cybersickness. These box plots further illustrate participant discomfort levels, specifically for typing and navigation tasks. Again, Natural Vision, or NV, has the lowest discomfort. Interestingly, for typing, GAP and direct pass-through show similar median discomfort, but DP has a much wider range of responses. For navigation, however, GAP clearly results in less discomfort than DP, closer to NV. This reinforces the idea that GAP is beneficial, especially in tasks involving more movement and spatial awareness. Finally, these charts look at interaction, discomfort, and overall preference. The box plot on the left shows NV with the lowest discomfort during the interaction task, followed by GAP and then DP. Then, the stacked bar chart on the right shows participant preference across all tasks. Overall, GAP is clearly preferred, reinforcing its benefit in reducing cybersickness and improving the VR experience. These box plots show the Simulator Sickness Questionnaire results for disorientation and total sickness scores. Similar to the previous plots, GAP and Natural Vision have lower median scores than direct pass-through, particularly for the total score. This further emphasizes the overall benefit of GAP in reducing cybersickness across various symptoms. So wrapping up this fascinating article by Google Research on Geometry Aware Passthrough, the key takeaway here is that GAP significantly reduces cybersickness compared to direct pass-through in VR headsets, particularly nausea and disorientation. This is largely due to GAP's ability to correct geometric distortions, leading to a more natural visual experience. Well, that's all for this week's AI Research Roundup. Thanks for listening.